Your agent worked perfectly in testing, and then it hit production and started throwing cryptic recursion errors the moment one agent tried to hand off work to another. If you've ever watched a nested delegation call spiral into a Stack Overflow or a silent infinite loop, you already know this pain. The frustrating part is that the crash usually isn't your logic. It's the framework's delegation model fighting the way you structured your agents. Let's start with what nested agent calls actually means, because the term gets thrown around loosely. You have a manager agent that receives a task, decides it needs help, and calls a subagent. That subagent might call another agent, or worse, call back to something that eventually loops to the manager. Each of these calls carries context, tool access, and a slice of your token budget. When the nesting goes wrong, you don't get a clean error. You get exhausted context windows, duplicated tool invocations, and calls that never resolve. In LangChain, delegation historically runs through AgentExecutors and, more recently, through LangGraph's explicit state machine. The classic AgentExecutor approach is where most crashes originate. When you wrap one agent as a tool for another, LangChain treats that subagent as a black box function call. There's no built-in depth limit unless you set max_iterations, and if your subagent decides to call the parent's tool again, nothing stops the recursion. The framework happily lets agent A call agent B, which calls a tool that triggers agent A, until your API bill or your stack blows up. LangGraph fixes a lot of this, but only if you use it deliberately, because LangGraph models your workflow as an explicit graph of nodes and edges. You decide exactly where control flows. You can add a recursion limit at the graph level, and when it trips, you get a clean graph recursion error instead of a mysterious hang. The trade-off is that you have to think in state. You're no longer letting the LLM freely decide who to call. That structure is exactly what prevents the crash, but it also means more upfront design work. CrewAI takes a different philosophy. Delegation is a first-class concept. You enable allow_delegation on an agent, and it can ask coworkers questions or hand off tasks through built-in delegation tools. This feels magical at first because you barely write any orchestration code. But here's the trap. CrewAI agents delegate through natural language descriptions of their coworkers, and when two agents both have delegation enabled with overlapping responsibilities, they can bounce a task back and forth. Agent A delegates to B, B decides A is better suited, and you get a conversational ping-pong that burns tokens without a hard stack crash, but with the same practical result. Nothing gets done. So why does one crash loudly and the other stall quietly? LangChain's older executors fail on actual call stack depth and iteration counts, which surfaces as recursion or timeout errors. CrewAI rarely hits a true stack overflow because delegation is mediated through the LLM's reasoning, so it degrades into semantic loops instead. The fix differs accordingly. In LangChain and LangGraph, you set explicit recursion and iteration limits and flatten your call graph. In CrewAI, you tighten role definitions, disable delegation on leaf agents, and use a hierarchical process with a single clear manager. The practical rule that saves you both headaches: never let two agents delegate to each other. Always cap depth explicitly, and make one node the sole orchestrator. Treat subagents as leaves that return results, not as peers that negotiate. Tomorrow I'm building a live hierarchical CrewAI setup with a hard delegation cap and showing you the exact config that stops the ping-pong loop for good. Subscribe so that fix lands in your feed the moment it drops.